Okay, today we are moving on to section 5.4, which is division of polynomials. So far throughout algebra and algebra 2, you've added and subtracted polynomials. That's where we just combine our like terms. We've multiplied using the FOIL method and really just distributing, but we haven't done division yet, and that's where we come in today. The first method that we're going to look at today is using long division for polynomials. And before we even start doing that with polynomials, let's kind of do a refresher of long division with just two numbers. Because I know some of you guys maybe didn't learn this method. Maybe you learned a different method for long division. So if I have the problem 5,436 divided by 6, here's how I set it up. The 5,436 goes under our bar here. The 6 goes out front. And I want to see, okay, how many times does 6 go into 5? Well, it doesn't. How many times does 6 go into 54? Well, I know 6 times 9 is 54. I'm going to put my 9 right above here. Then we multiply. 9 times 6 is 54. And subtract. 54 minus 54 is 0. Then we move on, bring down our next digit. How many times does 6 go into 3? It doesn't. So we put a 0 on top. 0 times 6, okay, we don't necessarily have to do that. Bring down our next digit also. How many times does 6 go into 36? 6 times. 6 times 6, 36. And subtract. So we end up knowing that 906 times 6 is 5,436. We don't have a remainder. Another one here, just a quick little example. If I have 1,239 divided by 4. Again, my first number goes under the bar. The 4 is going to go out front. 4 doesn't go into 1, but 4 goes into 12 3 times. 3 times 4 is 12. Subtract. Bring down our next number. Well, shoot, 4 doesn't go into 3. Put a 0 up top. Bring down our 9. 4, how many times does 4 go into 39? Well, this might take a second to think about. 4 times 8 is 32. 4 times 9 would be 36. And we have 3 left over. So our answer would be 309, remainder 3, which probably a better way to write that is 309 and 3/4. So I have 309 and 3/4. Okay, let's do this with some polynomials now. So I'm going to use that same process. We just have to be really, really careful. So my example, let's do x squared minus 3x minus 40. Divided by x plus 5. Same as before, my first term is going to go underneath the bar. The x squared minus 3x minus 40. And the x plus 5 is going to go out front. Now, when I'm working with my polynomial long division, I really want to look at my first term out front. My second term will kind of take care of itself. But look at our first term out front. I really need to be thinking about how many times does x go into x squared? And I know x times x gives me x squared. So I need to write my x on top. And when I write my x here, I want to make sure that my x lines up with its like term. So I don't want to write my x here, because then I'd have an x on top of x squared. I want my x to go here. And then I take x times this whole term that's out front, times the whole binomial out front. X times x plus 5 gives me x squared plus 5x. Here's the tricky part, the easiest place to make mistakes. We subtract just like we did with long division of numbers, but be careful you're subtracting each term. X squared minus x squared, those cancel out. Negative 3x minus 5x gives me negative 8x. And then just like our division of numbers, we bring down our next term, minus the 40. Look back to your first term here. How many times does x, or what can we multiply x by to get negative 8x? We can multiply by negative 8. Negative 8 times the x gives me negative 8x. Negative 8 times the 5 gives me negative 40. Again, make sure that you're subtracting and subtract carefully here. Negative 8x minus a negative 8x, those cancel out. Negative 40 minus negative 40 also cancels out. We end up with 0. So we don't have a remainder here. The next example, I'm going to show you one where we do end up with a remainder. And in my next example, we're also going to have a placeholder too. So it might not hurt to at least see how that example is set up, even if you don't watch it all the way. But it might help to see how it's set up first.